Can somebody confirm me my voice is audible and screen is visible?
Yes, sir.
Okay, cool. Fine. Good morning, guys. So sorry for the delay for today's class. Almost we are about 10 to 15 minutes late due to some miscommunication. Okay. So fine. So today we are going to discuss two important concepts. One is concept learning. Within concept learning, we'll be learning few algorithms. One is finders algorithm and second is candidates elimination algorithm and the problems associated with both of the algorithms. So today's agenda will be like this. So we'll see we can extend our discussion with few more concepts with respect to our problems with respect to these algorithms. So first is concept learning. So as soon as we dive deep into the our discussion, I just want to ask uh, tell you whether if we consider any concepts such as if I considered a bird or car, any object, any living thing, any non-living thing, or any other substances, it definitely belong to a category. Suppose for example bird belong to an animal category. Okay, so each of the concepts or objects which we can consider directly or indirectly it is associated with some set or some group which it is associated with. So concept learning is nothing but you'll be grouping each and every objects individually with respect to some hypothesis. So we'll be considering an example over here. So here my hypothesis is, or the situation which I can consider here is, I have a person called Aldo. He wants to play water sport. Okay, this is what the situation. Here, as you can see here, I have example in which I have about six attributes, that is sky, air temperature, humidity, wind, water and forecast. So there are about six attributes here, and then I have a column called enjoy sport here. So this is the result of all these attributes. So enjoy sport clearly tells that considering these all these three at all the six attributes, whether Aldo can play the water sport or not. This is the agenda. Okay, this is the final outcome. So here I have about six attributes. Sky, see, as you can see, sky is having two attributes here. One is I can tell it as an instance also, sunny and rainy. Air temperature is having warm, cold. Again, two instances. Humidity is having normal and high. Wind is having strong. Water is having warm and cool. Forecast is having same. Okay, same and change. So this is with respect to weather forecast. Okay, so my ultimate aim here is considering all these. If I consider example 1, for example 1, this is what the situation is. A day is sunny and the air temperature is warm, humidity is normal, and wind is strong, water is warm, and the forecast is same. If this is the situation, Aldo can play, enjoy sport, he can enjoy the sport. Let's consider the third situation, third example. See, in third example, the sky is rainy, the temperature is cold, humidity is very high, wind is strong, water is warm, and forecast is change. In this particular situation, Aldo cannot enjoy the sport. That is, it is no. Okay. So here, as soon as you get the answer yes or no, the situation, the Aldo can enjoy the sport. He can play the sport. This situation, we call this as positive example. Okay. So which we will be represented by plus or positive example. The situation where Aldo cannot enjoy the sport, for example, the third situation, the Aldo is not enjoying the sport. If this is the situation, we'll be considering it as a negative example. Okay, so what is the gist that we got it here? We have a situation where we have n number of attributes given an hypothesis. Hypothesis is a situation. Okay, it's a beginning of the situation. Let's consider the hypothesis 1, an example 1. See, in example 1, these are for all the given 6 attributes. This is what the situation which it has. These, see, in example 1, I have sunny, warm, normal, strong, warm, and same. These are all the specific things. Okay, these are all the generalized things. I'll be going with respect to our discussion. When we go further, I'll be telling what is general hypothesis and what is specific hypothesis. For this instance, you just keep it in your mind, what is positive example and what is negative example. So what do you mean by positive example? If the situation goes with a yes thing, that is Aldo is able to enjoy the sport, then it is called as positive example. If the situation is not possible, the final outcome is not possible, then I'll tell that it is a negative example. Okay, so this is the set of example for which, considering these, uh, see here, my target concept is enjoying the sport. Okay, so enjoying the sport is my target concept. So whether he is enjoying or not is my positive example and negative example. Okay, so positive instance or negative instance. So my attribute enjoy sport here indicates whether a person enjoys his favorite sport on this day. Okay, so here my main task is to learn whether he is enjoying the sport or not. So we'll confine our discussion here. We need to know three things here. As we know that it consists of 6 attributes. So in the table, I have taken 6 attributes like sky, air temperature, humidity, water, and weather, wind, and forecast. See, out of all 6 attributes, uh, each attributes in the hypothesis can be applied with 3 things. See, for each attribute, okay, if I have 3 notations which you call it as here. If a attribute is represented by question mark, as you can see here, the first thing indicated by a question mark, it means that it is a general hypothesis. Any value can be represented over there. Okay, for example, if I consider, we'll be going through, just keep in mind as of now. Second is specific hypothesis. I will specify, for example, I'll tell my air temperature is warm. Okay, I can tell air temperature is high, low, or warm. If 3 are my instances, I'll specifically tell that my air temperature is warm, so that I'm specifying, I'm not generalizing there. If I put a question mark there, my instances within air temperature can be any of the value. Either it can be warm, either it can be low, either it can be high. Okay, next I have third notation. Okay, that is null notation, which indicates that no value is acceptable. We'll understand when we take up an example. Please bear with me for the next 2 or 3 minutes, so that you'll be understanding what does that example represent actually. So a question mark is any value is acceptable. A null symbol represents no value is acceptable. And the third thing is any specific instance value which you are already assigning. Okay, so this is what the situation. Next, so here I'm having an example. Let's consider an hypothesis H. Okay, so H, which is classified as a positive example. So what do you mean by positive example? My hypothesis of x is equal to 1. I'll tell that it's true condition, which I tell that it is a positive example. So now let's consider a hypothesis which here the person enjoys his favorite sport on cold days with high humidity. As you can see here, see, please observe here in the table. So first is my sky, air temperature, humidity, wind, water, and forecast. Out of 6 attributes, he has taken here first attribute as general instance. So it means that, see, here I have question mark, comma, cold, comma, high, comma. Again, I have three question mark notation over there. It just represents that how many instances are present here. Of course, it has 6 instances. Out of 6 instances, I have 4 question mark, which it means that it is a general instances. Any value can be applied over there. Okay. So, and 2 instances are specific instance. I'm specifying that it is cold. I'm specifying that it is high. Okay. So his cold days with high humidity. So please go back to this thing. My sky value can be anything. It can be rainy, it can be sunny, and my air temperature must be cold. He's telling it must be cold. Please observe the third column, humidity must be high here. The humidity must be high, and rest all other three things can be any of value. Wind can be either strong or weak, water can be either warm or cold, forecast can be either same or change. So all the last three is represented with question mark again. So this we call it as, this is a positive example. Okay, if this is the case, if the day is cold with a high humidity, he can play the game. Okay. Did you just anybody can unmute yourself, and can somebody confirm me whether you have understood this?
Yes, sir.
Okay, thank you. Next, we'll generalize. If we want to generalize this hypothesis, now we have the situation where a day has to be cold and the humidity has to be high, and any other attributes can be any instances. I can play the game. But my main intention is I don't want the day has to be cold or it has to be humidity. All my attributes can be of any value, so that we will tell that it is a general hypothesis. If all the attributes are represented by question mark, the day is general hypothesis. Any value for any attribute is acceptable. Then what is the abrupt situation, or the opposite situation which we can have? The most specific hypothesis day, that is, no day is a positive example, that all the attributes are replaced by null symbol. Okay, so one is with specific values, or few specific values and few general values. Second situation is we all have the general hypothesis, that is by question mark. Third situation is we will all be having null values as all the attributes in my hypothesis. So one is positive example, another one is negative example. Can we go further?
Yes, sir.
Okay, thank you. So we'll be using few notations here. See, observe the, as you are observing the presentation here, we are having these are the set of items which we call it as an instance. Okay, so here I have many instances. For example, capital X is a set of all possible days. So in that set, I have about 6 attributes, that is sky, air temperature, humidity, wind, water, and forecast. So these are all the 6 attributes which I can tell. See, out of what is my target concept here? See, target concept means whether he is enjoying the sport or not is my target concept. So it is represented by small c here, which we denote it by small c. So c is a target concept. It can be a boolean valued function. Either it can be 0 or it can be 1. So either it can be 1 means it is positive instance or positive example. 0 means it is a negative example. Okay. So that is example at last of the present, last line of the presentation in bracket here specifically given. If c of x is equal to 1, it is enjoy sport is equal to yes. If c of x is equal to 0, it is no or negative example. Okay. I have jotted down few points over here. Please observe. If c of x equal to 1, it is called as positive example. If C of x is equal to 0, it is called as negative example. The ordered pair, if you could remember the yesterday's example, at ordered pair is nothing but you will be having a training example. So x, small x is the training example. What is the target after after applying the target concept C to that particular training example? What is the value? That is small x comma target concept C of x, so that you are applying the target concept to that particular training example. What is the value? That is one particular set. D denotes the available training example. So out of 100 training example, let us say we have about 100 training examples. Out of 100 training examples, I will be applying about 50 training examples to my target function. Okay. And also H represents, capital H represents all possible hypotheses, and small h represent a single hypothesis, one particular hypothesis. Okay. So a small hypothesis is denoted by, is calculated by the output of the set, that is x. What is my x? Here it's a set of the boolean valued function. Okay, either it can be 0 or 1, that is positive or negative examples. So h will be told that it is a positive example or a negative example, considering the values or the instances which is present within your set of x. Okay. Next, finally the goal is find h of x which is equal to c of x. That is my main ultimate aim. That is, my existing hypothesis achieves the attributes which are associated with the target hypothesis. Okay. If that is my target function, I want my hypothesis to be same or to be nearly same as my target hypothesis. Okay. Is there any doubts with respect to the notations which is present over here? Should I repeat it anything? Please unmute yourself and confirm me once again whether I can go further, or if you have any doubts.
Yes, sir.
Can we go further? Okay,
Yes, sir.
fine. He has again took the same example. I'll be taking the same example. Here again he has jot down. See, this is what the enjoy sport concept. See, concept is enjoying the sport, where I'm having instances. What are all the possible days? That is, I have 6 instances: sky, air temperature, humidity, wind, water, and forecast. Okay, these are all the attributes. Okay, within attributes I'll be having instances with values. For example, sky is having the values sunny, cloudy, rainy. Same manner, I have about values for all the 6 attributes. That is my instances. Second is my hypothesis. So hypothesis is a set of all attributes which you can tell. What is the set which I am having? That is sky, air temperature, humidity, wind, water, and forecast. All the 6 set. Next, my target concept C. That is C is represented by what? What is my target concept? Enjoying the sport. Colon. That is, it is dependent on X. The X can be either a positive day or a negative day, or a positive example or a negative example. And we have the training examples D. So this determines, okay, this it is the juice of all the concepts. So enjoy sport concept, which we have considered over here, has all these things. It has instances X, hypothesis H, target concept C, training examples D. We have to determine my small h, that is my individual hypothesis, out of my existing hypothesis, that is capital H, such that my individual hypothesis, that is h of x, is equal to my target hypothesis, that is c of x, for all the possible combinations of x. See, please observe here. Small x is the instances. For example, sunny, cloudy, rainy are all small x. What is capital X? Sky is your capital X. That is one of the values. Okay. Are you understanding?
Yes,
Yes,
sir.
sir.
Can we go further? Yes?
Yes, sir.
Yes, sir.
Okay. Okay. Fine. So please bear with me for the next few minutes so that we'll be coming up with a few examples so that you, if you understand this clearly, see that you just watch the PPT again so that clearly understand what kind of hypothesis which we can accept here. Okay, so we are considering about 6 kind of attributes are here. If I apply my hypothesis to my existing 6 kind of attributes, what is my final outcome? Whether it is a positive day or it is a negative day, or if I am getting a general hypothesis or am I getting a specific hypothesis? Okay. So next we have inductive learning hypothesis. So it's a sub concept which you can consider over here. There is nothing special over here. See, if I consider the previous example, let's come back to the previous example. Please try to understand there. We have about six attributes. Okay, so directly come to the example point of view. I have an instance that is capital X, that is my overall set which I am having, and a hypothesis H, capital H, in the enjoy sport learning task. We have a learning task over there. So it has 3 possible values. See, the attribute which he is specifying is the first attribute, that is sky, is having 3 possible values, that is small x values, that is x1, small x1, x2, x3, and air temperature, humidity, wind, water forecast, and all the rest of 5 attributes are having 2 possible values. Try to understand. I'll be repeating again here. The attributes called sky is having 3 possible values. So sky is that is my first attribute. It is having x1, x2, x3. Okay. Next, apart from sky, rest all other values are having 2 possible values. The instance space or the whole set will be considering exactly what is the total number of possible values which we can have. That's the combination of all. Okay. Here he has specified that what is the values which I am having. Sky is having, so 3 into, for all the attribute it is having 2. So I'll multiply 2, 2, 2, 2, 2. So 5 attributes I'll multiply by 2. If you multiply the whole term, that is 3 into 2 into 2, 2, 2, 2, we will be getting 96 distinct instances. Can somebody confirm me whether you have understood this?
Yes, sir.
Okay.
Yes, sir.
So the second instance, please observe carefully there. See, apart from, this is the general thing which he has given. Apart from the specific example, see, sky has 3 possible values. Air temperature, humidity, wind, water forecast are all having 2 possible values. Apart from this set, I am having 2 other possible combinations. Can anybody tell me what are all the other possible combinations of the whole set? Can somebody try to tell me?
Question mark and
The
null.
whole set can be question mark. That is, it can accept any possible combinations. Okay, so that is my general hypothesis. Or it can also be null symbol. That is my specific hypothesis. That is, no value is acceptable. So that is the 2 possible situations which an extra situation which it can have, which we call it as syntactically distinct hypothesis within H. So I will be adding 2 instances to all the attributes so that 3 plus 2 will become 5. then all the 2 is added with other 2 instances, that is it will become 4, so that it has become 5 into 4 into 4, that is it is equal to 5120. This is the possible combinations of distinct hypothesis within my specific hypothesis. There is my concept clear?
Yes, sir.
Yes, sir.
Okay. Now let's imagine guys, okay, we'll remove one negative. Okay, we'll take out the specific hypothesis situation only, that is all the values in the set is replaced by null symbol. That is one situation. If all the symbols is replaced by negative symbol, it means that it is a negative example. The outcome is 1. Okay, it clarifies every instance as negative. That is one set which I am considering. Apart from one set, plus what is the remaining thing? If I remove 1 from every instances, 5 will again become 4, all the 4 will again become 3. That is 973 distinct hypothesis. Okay, so distinctly hypothesis with respect to your negative example is an possible combinations. As a whole scenario, if you can observe here in this presentation, you can three possible cases. One is whatever the thing which he has given, we have considered that we have applied the possible combination, that is 3 into 2 into 2, that is we have 96 distinct instances. Second thing is we'll apply all the things, that is including your general hypothesis and specific hypothesis. The third situation, I will take out the negative hypothesis, I will remain with all the possible hypothesis instances. What is the combination? So here 3 things we have got. Can we go further?
Yes, sir.
Okay, is there any doubts?
Yes, sir.
Can we go further? Yes.
Yes, sir.
Okay, thank you. So general to specific ordering of hypothesis. Here, if you can observe, we have 2 hypotheses. One is H1. H1 is having sunny, second attribute is general, third attribute is general, fourth is strong, fifth is general, and sixth attribute is general. Then H2 is my second hypothesis, where I'm having sunny again as my first attribute, second, rest all other things as general. If you can consider this, can somebody confirm me which attribute is more I can go with? This is what the hypothesis I can go ahead with. I can enjoy the sport. Which hypothesis can I consider here?
H2.
H2. Why H2?
Because more
Fewer
positive
constraints.
examples will come.
Yes. So H2 is having, H2 can be considered positive example when compared with H1. Why? Because H2 is having more general things. Any value, my from your second attributes to my sixth attribute, it can be of any values. I don't bother any attributes, any instance it can be. If my day is sunny and any other attributes can be anything, I can play my water sport. This is what it is going to convey there. Okay. Next, I can generalize with a few more example. So we have definition here. I'll come back to this definition here again. Okay. I'll come back to this formula and explain you what it is. So here, given a specific hypothesis Hj, let us consider one hypothesis Hj and another hypothesis Hk. I can tell that Hj is more general or equal to Hk when any instances that satisfy Hk can also satisfy Hi. Okay, so he's taking another hypothesis over there. So overall, telling an overall view, if my hypothesis consists of more general terms, I can tell that it is a positive example and I can correlate with the previous hypothesis. Well, we can just have a clear comparison when we take up a problem which is based on this hypothesis. Okay, I'll come back to this again. So it's a diagrammatic representation which you can observe over here. One is your instances X, that is overall instances what all we have, and the hypothesis a Venn diagram also, which you here it is just representing all the types of instances. Okay. Second is the hypothesis. Please don't get tense while looking at the diagram. There is nothing with the diagram, just it is representation of instances and hypothesis. The right side of the diagram clearly indicates that there are about 3 hypotheses which is associated with some or the other thing. Okay, so H1 is associated with let's say H2, H3 is associated with H2 over here. So it can be one particular hypothesis can be consisting of n number of instances. Okay, when we take up the problem, we can clearly understand what is the difference which it is having. Let's assume, see, imagine a situation. We have an algorithm to solve this particular problem. So algorithm, the name of the algorithm is find as algorithm. The main intention of this algorithm is to find a maximally specific hypothesis. Okay, so finding the maximum specific hypothesis is my main intention. So algorithm, the steps of the algorithm goes like this. First we'll initialize, the very first step is initialize the hypothesis small h, that is only one hypothesis out of all hypotheses, to the most specific hypothesis. So he is whatever the hypothesis it is, he will initialize it to specific hypothesis. That is the training example, whatever which he has given, I will initialize it as small h. Okay, next. You'll be clearly understanding when we take up a small problem with respect to this algorithm. Okay, so next we have a positive training example. For each positive training example, what do you mean by positive training example? Which the solution is positive. Okay, I can play the game. Yes is my positive example. If the place port is no, it is negative example. Okay, so when I tell that the enjoy sport is a positive example, for each attribute which is constraint which I can tell in H, it must satisfy the given instances. Okay, we'll go to one problem. Okay, I want to take up a direct example over here. Okay, we have an example to illustrate this algorithm. Please observe the algorithm now. Assume that the learner is given a sequence of training examples. So enjoy sport is my task. I have 6 attributes. I have the last column which you can observe there, that is my enjoy sport. Whether he is enjoying the sport, that is yes, or it can be no. Yes means it is positive example, no means it is negative example. What is my first step? Initialize my hypothesis to specific hypothesis. So specific hypothesis means what? I'll replace all the attributes by null value. So H is equal to all the 6 attributes by null value. What is my second step? I will consider the first example. Observe the example number 1. Example number 1, sky is sunny, warm, normal, strong, warm and same. These are all the attribute instances of example 1. I will consider this as x1, that is instance 1. See, x1, after writing it within the braces, you put a comma and you will be writing whether that particular instance is a positive example or a negative example. How you will write? You will observe the final outcome, that is enjoy sport. For the example 1, what is my enjoy sport value? It is yes. So that I will be replacing the instance x1 by plus. I will be considering this particular instance as my hypothesis, that is H1. The same x1 is considered as my H1, that is sunny, warm, normal, strong, warm and same. The hypothesis is same. Next, Please go to the table now. Please look at the table. The second example which we have, please consider that particular example as x2, my instance 2. So my x2, is it a positive example or a negative example?
Positive.
Positive example. So x2, I'll write down the value of x2, comma, what is my value? It is a positive example. Now compare the value of x2 with h1. My first attribute Sunny is same. Second attribute, both of them are warm. The third attribute, one is normal and one is high. Fourth attribute, one is strong, both of them are strong. Fifth is warm, sixth is same. So there is only one change over here. That is my hypothesis. I can rewrite my hypothesis. I'll update my hypothesis from H1 to H2, keeping all the attributes which are same as it is, and I will replace it by the attribute which is changing, that is normal to high, by general hypothesis. Can I do that? Either it can accept I'm generalizing the thing, either it can be normal or it can be high. Did you understand?
Yes, sir.
Yes, sir.
Can we go further?
Yes,
Yes,
sir.
sir.
Okay. Now, can somebody help me to find out the hypothesis 3? Please observe. Write down in a sheet there. Can somebody explain what is hypothesis 3 value? Quickly, can anybody just work out and let me know what is the hypothesis 3? Write down the example 3 there. Please write down the example 3. Okay. And just let me know what is the hypothesis 3.
Same as hypothesis 2.
Same as hypothesis 2. Can you give a justification for that?
It is because it's a negative example. Finders doesn't consider negative examples.
Yes, exactly. So x3, if I consider, please observe guys, x3 here, I'm having rainy, cold, high. These are all the set. Consider example 3, which is a negative example. Finders do not consider negative example. So whatever the hypothesis, observe x3 here, please write down the x3, comma, it's a negative example. So my previous example, I'll compare x3 with h2 here. If I consider h2 with x3, it just neglects x3 value, this instance, it will remain the hypothesis as h2. So h3 hypothesis will be remaining same as h2. There is no change, that it is neglecting the negative hypothesis. Next, when it compared with x4, I have another instance. It is a positive example. So we'll start comparing now. Sunny is same. Second attribute, warm, is same. Third attribute, in H3 it was general. In X4 it was high. I will make this as general hypothesis. Did you understand?
Yes, sir.
Okay. Strong, I will keep it as same because it is common. Warm and cool, it has changed, so that I'll replace it by question mark. I'll make it general. Same and change, I'll make it question mark. So I'm making it as general hypothesis. So this is a small example. So H4, see what is the total number of examples that I'm having here. H4 is the last example. Considering this particular table, out of 4 example, what is my final specific hypothesis which Aldo can place port? So it is the specific example when the day is sunny and the humidity is warm or the wind is warm and the breeze or whatever the thing, it is strong. Rest all other things, it can be generalized hypothesis. Okay, so this is how we solve the problem here. This is the representation, which is not much important. The same representation with respect to our instance and with respect to our hypothesis. So this is about Finder's algorithm. So in findus algorithm, this is the output. The findus algorithm is guaranteed with the output that is most specific hypothesis within capital H, that is final hypothesis. It can consist of negative example, but it will not be, your target concept will not be considering your negative example. This is the property of findus algorithm. There are few unanswered questions by findus algorithms which we have observed. Has the learner converged to the target concept? Okay, it means that the target function, has it achieved by coming nearby all the values which are accurate to the target concept, or is there any most specific hypothesis which is there? Why prefer the most? Why should we prefer most specific hypothesis only? Why can't we take the general hypothesis there? The third situation is, are the training example consistent? The training examples are changing here. In my case, when you go for exam from example 1 to example 2, example 2 to 3, 3 to 4, your values or the instances which are present over there are changing time to time. So why are they changing? So what are all the different types which we can expect over there? So what if there are several maximally specific consistent hypotheses? If in our example, I had considered only 4 example in my total capital hypothesis H, I have considered only 4 example. Let's assume that we have about 1000 examples. Out of 1000 example, if I have one attribute out of about let's consider I have about 1000 example with 5 attributes, and out of 5 attributes I have 2 attributes same throughout all the 1000 example. That is maximally specific consistent hypothesis. Okay, so those are all the questions which is not being able to answered by your findus algorithm. Why? Because it doesn't take your negative type of example. Okay, negative instance or the negative example which it is not considered. So to overcome this particular thing, we have a concept called version spaces and another algorithm which overcomes the disadvantage of your findus algorithm, that is your candidates elimination algorithm. So we'll be discussing your candidates elimination algorithm in the next discussion when we take up. So this is the whole concept which we had thought of delivering it today and discuss having a discussion of this concept. So at most, giving a gist of all this, we try to understood what is concept learning tasks. Taking an example of enjoy sport as an example, we knew what is a concept here. Within concept, what are all the things which it is associated with? So it is associated with these things, that is instances, hypothesis, target concept, training example, and the complete hypothesis. And when we try to solve by applying one of the algorithm called findus algorithm, what are all the types of advantage, what are all the steps which we use to which are used in finding the most specific hypothesis which we have studied today. Okay, so this is all our discussion. If you have any doubts, you can just unmute yourself and you can ask me any doubts if you have for the next 2 or 3 minutes.